In this video we're going to do MA3D5 Galois theory term 1 assignment 1 question 6. So 6a says show that there does not exist an element alpha in the real numbers such that alpha squared is -1. Alright, so this is not really an algebra problem, so let's actually go through the cases. So we'll suppose alpha is 0. Well, clearly that can't be possible. So the other two options are either alpha is bigger than 0 or alpha is less than 0. Or in this case we could say negative alpha is bigger than 0. So this is by subtracting alpha from both sides. So this first case, because alpha is positive, we can multiply both sides by alpha. So we get alpha squared is greater than 0 times alpha, which is 0. And so alpha squared is bigger than 0, but -1 is clearly less than 0. So alpha squared cannot equal -1, right? In this case, where alpha's less than 0, or maybe this one, we can do the same thing. We can multiply both sides by minus alpha because it's positive. So we get minus alpha times minus alpha is bigger than 0. And minus alpha times minus alpha is alpha squared. And so again we have alpha squared is bigger than 0, right? And this means alpha squared cannot be -1. And the key fact we're using is -1 is less than 0, right? This is the key fact. Okay. So the second part, right, part B, it says that show for all d less than 0, where d is a real number, that the degree of the extension r adjoin square root d r, where r is a real numbers, is equal to 2. Alright, to do this we're going to use the fact that the degree of the extension is equal to the degree of the minimal polynomial of this square root of d. So we can write this degree of this is, so this is going to be the proof, degree of f, where f is the minimal polynomial of square root of d. Okay, so the question now is, what is the minimal polynomial of the square root of d? Well, we know it's not going to be a linear polynomial. We know it's not going to be x minus some a, where a is a real number. I wanted to have real coefficients. The reason f can't be this, is because we showed that the square root of d, where d is negative, we showed that negative numbers, and this we particularly showed that -1, but this argument works for other negative numbers as well. We showed that negative numbers, they don't have a square root in the real numbers. So if I plugged in square root of d and got 0, then it would mean that a was a square root of d, which is impossible, and so it can't be of degree 1. But what about degree 2? Well, in this case it does work, so we can do f is equal to x squared minus d. And in this case, if you plug in the square root of d, then this becomes 0. And since we showed it can't be degree 1, but there is an example of degree 2, then the degree of the minimal polynomial is 2. In fact, this is the minimal polynomial because it's monic. Okay, so that means the degree here is 2, and so the degree of this extension is 2. So that's the end of proof. Thanks for watching.